I am so excited to start Trig, but let me back up my excitement and actually tell you what Trig is really quick. Trigonometry is how we relate sides to angles. We already know in a right triangle that if I know, well, we already know in any triangle, if I know two angles, I can find the third one using that they all add up to 180. And we also already know that if I have two sides in a right triangle, I can use Pythagorean theorem to find the third one. Trigonometry is what we use if we only have one side and one angle, and we're trying to find other information. So if I only have one side and one angle, this is where trigonometry comes in handy. If I have two angles, I don't really need it usually. I can usually use if I'm trying to find another angle, or if I have two sides, I'm trying to find another side. But if I have an angle on a side, I'm trying to find something else, we use trigonometry. Not important, but I thought it was kind of cool. So trigonon is one of the root words of this, which just means triangle. And then metron means measure of. So we're trying to measure triangles. That's it. That's all we're doing. Now there are three main trig ratios or trigonometric ratios. There are sine, cosine, and tangent. And this is how we write those words out. But when we're doing math, mathematicians are lazy. We don't want to write out all these words. What we write instead is we would write SIN of an angle. Now we use Greek letters for angles and English letters for sides. So this is theta. Say hello to theta. I actually do my thetas a little bit weird. I'm going to tell you how to actually do it in a second, but bear with me. And then cosine, we write COS, but we still say cosine even when we see the word spelled COS. And tangent, we write TAN, but again, we still say the word tangent even though it's written as TAN. So sine of any angle is going to be the ratio of the opposite side over the hypotenuse. And we'll define all three of these in just a second, so bear with me. I just want you to have these notes written down. And then cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. TOA. Yeah, okay, good. Ta-da, box. Okay. I don't know, it's just fun. I'm going to define all four of these things, the theta, the opposite hypotenuse, and adjacent sides in just a second, but I just want to show you that whatever the angle is, this ratio will always be the same. That's why it's a ratio. So for instance, if I had sine of 30 degrees, it'll always end up being 1/2. If it's sine of 50 degrees, the ratio will always be about 0.766. We usually like to end up with decimals instead of fractions when we do this, but 1/2 or 0.5, 0.766, or I don't know what that is, root 3 over 2 or something like that. We'll get there. It's fine. These will always be the same. So no matter how big or small the triangle gets, the ratio will always be the same. That's why we have to kind of figure out the scale factor when we do this, but we will get into all of that, I promise. Okay, now I have a right triangle here, and we know it's a right triangle, so it'll have a little symbol here. But I just want to warn you right now that sine, cosine, and tangent only work for right triangles, just like Pythagorean theorem only works for right triangles. So we're going to have something a little bit different when we get to different shapes of triangles. It will relate to this, but we'll get there. It's fine. Always has to be a right triangle from now on, though. So for any right triangle, the longest side is always the hypotenuse. That's the longest side. That's why my I have so many of these, I need to give them away. That's why my little hippo guy is on the longest side, because it's the hypotenuse. It's actually a hypotenuse, but it's fine. You know, it's fine. Okay, now here's the trick to this, though. I need you just to hear me out. Opposite and adjacent can switch depending on where the angle is, okay? So let's just say that this right here is the angle that I'm working with. This is where my perspective is from. So right now, I guess I'm flying or something. This is my angle theta. Okay, now theta is a circle with a line right in the middle. I got real lazy back when I did this a bunch of times, so I started kind of connecting it all and it made this swoop. Some people get mad at me because this looks more like a sigma than it does a theta. So I'm just gonna get a sticky note real quick. I have 2 sticky notes left. Okay, I'll find more. It's okay. So oh no. What? Theta is like this, and a sigma is like this. I don't care. I'm only telling you because sometimes teachers care. Sometimes I got in trouble a couple times. So that's called theta. I wish I knew why. I'll look up y and see. Okay, so if I'm standing here, then the side across from me is the opposite side. And the other side is the adjacent side. I always do in that order because adjacent is I can touch it, right? So if I'm standing here, I can touch this side, but I can also touch the hypotenuse, which is why we put the hypotenuse down first, and then we worry about the other two. Because the hypotenuse is always across from the 90-degree angle, or it's the longest side. Opposite is across from theta, and adjacent is the other one. I wish I could tell you to watch my video in the notes, because y'all are here, but I don't know, you're not. It's fine, it's okay. But I just want to reiterate that it depends on where I'm standing. So I could also do the same triangle from this angle, and then my opposite and my adjacent would have switched places. Oh, and I can never be standing at the 90-degree angle because opposite is the same as hypotenuse then, and then they're both adjacent, and then everything falls apart. So it has to be one of the other angles that is not right. All right, so I'm going to do an example where I'm going to find sine, cosine, and tangent of this triangle at theta. The theta means that I am standing right here. Here's where my perspective is from. So I'm always going to draw a little dude. I'm going to even put the steps over here. Step 1, draw the little dude. Then I'm gonna label the sides. So again, the hypotenuse is always the longest side. So it's 5. The side across from the little dude is the opposite side. And the other one is the adjacent side. Okay, so my sine theta is equal to opposite over the hypotenuse, which is equal to 3/5. I can change this to a decimal if I so desire. Normally we leave them as fractions, but if it makes your heart happy, we can do it as a decimal too. So that would be 0.6. Okay. Cosine of the angle is equal to adjacent over hypotenuse, which is 4/5, which is 0.8. And then tangent at this angle is opposite over adjacent, which is 3/4, or 0.75. So these are really my right answer. These are my final answers here. But the decimals are just fine as well. Okay, now I know you're wondering why are we doing this. Okay, today, this lesson, all I want you to do is be able to identify sine, cosine, and tangent so that way it fits for you. But the very next lesson, this same week, I'll be wearing the same thing still. We're going to use sine, cosine, tangent to find missing angles. No, missing sides. Next week is missing angles. Sorry. So we're going to use the fact that sine of anything that's in this shape has a 0.6 as the ratio. So what I'm going to give you is I'm going to give you a blown up version of this where maybe it's 8 and 10 and we're trying to find this one. And then we'll use the same ratio to figure out. Actually, I won't. I'll only give you the 8. And that this is the same angle as before. And then we'll have to figure out that this one would be 6. That's all we're doing. I'm rambling. I'm going to put the steps under here so you can figure out. You can write them down if you want to. You can look at the notes, but I'm glad you're here listening to me because this is a lot of important information that's not just going to be written down. Y'all should start watching these. Tell your friends. Okay, that's it. Goodbye.